Twitch, hello YouTube, hello world. We are starting our streaming, our video. First of all, I'm really sorry about yesterday. Yeah, yesterday I had a power outage problem. Brazilian stuff. And then I get back. When I got back, I had to fix some things, so I stopped it earlier. But anyway, yesterday was a very good. Oh, let me play some music for us. So yesterday was a very good. We had a very good progress. We finally see something in the screen. Let's see it again. So here we are. We are with this R but inverted. I think I know how to fix it. I will. But I think the problem here is simple. As it is inverted in the horizontal line, I think it has to do with the lines that are written in inverted order. Instead of doing this way, it's doing this way. So I think the easiest way to fix that is to change the J here. So maybe doing this range in reverse. Oh no, doing this range in reverse, maybe it will make it not works, because the bit pair will not work as well. So I think it's easier to do this, like 7, yeah, because 0 to 7, yeah. If we put 8 here, when it's 0, the address, yeah, the address cannot, yeah. So then it will print in the reverse way. So if we, oops. What's that? What's this? Okay. What is it? Okay. So yeah, it fixes. It fixed. So now we have. Hey Marivan, how are you doing, man? Thank you for watching. Thank you for watching my stream. You said this is not so useful code, but it actually is. We are learning a lot creating this emulator here. So let me do just zoom a little more. Wow. Okay. So yeah, we are doing here. We already have our R here. Great. Now we need to do the actual stuff. So first of all, we are still doing like wait, Now it's too close. Yeah, okay, that's good. So we are still this tile is coming directly from the tile set, and that's not what we want. Of course, we want to read the tile from the tile map, and then it will be able to put it in the right place in the screen. So let's do it. We already have this way to read the tile set. As I said, I will just rename this from get bg tile set, get background tile set to get tile set, and I will create a new one called get tile map. It will also receive self because it's a method, and also receive the memory management unit, and it will return from what we learned. Phantom. Wow, we already have 5 viewers so soon. Thank you, everybody. So, in our graphics, we want to copy the tile map from this address, and the tile map is actually the background map is as previously mentioned. Is 32 by 32 tiles. This comes to So as we are representing a tile set, a tile as an integer. Oh, but actually the tile map, I think the tile map is just the pointer for that level. Let's see what is there. So let's do not return anything for a while. What's this? What this is brown? What's the problem? There is no problem. Okay, so let's do this. Let's just print out the what is in the memory address. So yesterday we also saw that from this LCDC we are using this map from. So I will just print out this memory address. So I will do this, and well, actually not here. Oh, actually I can do this. Yeah, no problem. I can. So let me do different. I will do this way. Here in the memory, I will create a pub function get mem slice. address from address start no. From to and I want to have like how can I do this? Oh, I will not do this way. I will just create the BG tile map is already being printed in this, so I will do this in our I will do not here, I will do here print man. So I'll do our state and yeah, like this. Okay. So then we will be able to see I think this is the tile map. So this is the tile map, right? So what is there? 1, 2, 3, 4, 5. Oh, that's weird. Let me see what we are printing here. Oh yeah, we are printing everything. Actually, let me just print what we are using and just print here like this. So these are the tiles, tile set and the tile map that we are actually using. So it seems that it's pointing directly to addresses there. So this, oops, I think it's here. Documentation, video display again, tile map. So BG map tile maps. Another big ones. Yeah, so that's it. Hey Dan, endianness gave me quite headache today since I decided to use U16 for all my registers. Oh, are you doing that Z8? Yeah, you in the endianness. I mean, in big endian, you need to reverse. We have this here. If we see in our decode, in our decode, here, inverting position because it's big endian. Yeah, so sometimes in the Game Boy emulation, if we get only 8 bytes, it's okay. If we get 8 bytes separated, it's okay. But when we get our those 16 bits, sorry, we need to put this in the reverse way because of that big endian. Yeah, I learned that in the very first episodes of this series, and is weird. I mean, because in Game Boy sometimes is that way, sometimes not. So that's weird. So did you start with that Z8 emulator? You said yesterday. So yeah, so we saw that there it's numbers. So our tile set is numbers. Tile map is numbers. So let's get back there. Let's get our tile map. If that's only number, I can put it as an U8. Yeah, it's a U8 because the tile set is only 250. And it has 32 tiles. Yeah. So yeah, it is an array, sorry, an array of big tile map. An array of 32, no, 100. Yeah. So 1 mega, 1 kilobytes. That's too much. But I think that's it because it's, yeah. So how to return? This way. Tile map. It's okay. So it starts on yeah. So now we have our tile map, right? Actually, here doesn't matter. I can put even we use size because this is just a number. But let me put this. I think this is actually we use 16. Oh. And what's the problem here? Oh, this is not get a tile. This is directly This is I think that's it. I think now it's okay. What's the problem? Oh yeah. Yeah. Sorry. The problem is that actually we are reading bytes, right? Not yeah. So that's it. We are. What's that? What's the problem here? I think that's. Can I do this? No, I can't. Yeah, I don't need that cast, but why? I mean, I want to just some. So our initial value is here. So I want to get all the next. Yeah, but it's still complaining. I can cast this, but then it's still complaining. Oh no, I think it's my IDE that's too slow. Here it's still complaining, but the oh, maybe this. Let me try to restart this IDE. And see if it works. Did you guys know this Pokemon Pocket Go emulation stuff? This is nice as well. I have a lot of these emulation device. I have this Odroid Go, I have this, some other stuffs. Nice little boards. I like to mess with hardware as well. Besides, I also need to learn. Okay, so back to work. So now we have a way to get our tile map, right? And we have a way to display one tile in the screen, but we want to display the two. We have 200 so the screen of Game Boy is nope, not here. Maybe here. Yeah, so it's 200 here. It's 200 pixels by 200 pixels, but the visible area is 100 by 144. So that's why that's why our screen, this screen, is 160 by 144. But our actual background, in other words, in our background tile map has 256 pixels. That's why it is 32 per 32 tiles, right? So 32 times 8. Ta-da! So that's the size of the pixels. So right now we have, here. So right now we have this tile map which points us to the tile set. So now we have a use for our buffer here. Our buffer is, because our buffer is actually, let's rename it. It's also actually our background buffer. Let's name it this way. So this is our entire screen, entire background, and the register SCAX and SCAY will tell us which one should be printed here in the screen. So we need first to map from tile map from tiles data to tile map into so now I can do this. Let's create another function here, another method actually. That method will be used to transfer, to put our BG background tile map, our background tile set inside our total screen using the background tile map. Okay, so let's call populate background buffer. So our 256 per 256 pixels, we will call that background buffer. So let's populate the background buffer. What we're gonna need? We will need, I think, just self and memory management unit. We don't need anything here, and also we need a mutable self. Why? Because we will actually mutate our background buffer. Right? Right. Music stop. Let's change the music. So okay, bossa nova. Ah, let's put some Brazilian stuff. Uh, okay. So how you gonna do? We gonna do that? First of all, let's get our let tile set self get tile set. And how we do that? Just passing and okay. Now we have our tile set. And our tile set, it's tile. Oh, we need to remember that little tile is still a tile in format of Game Boy, not in minifb tile. We need to populate that with minifb. So let's recap here. We need to get the tile set, get the we need to get tile set, get the tile map. Populate the background buffer accordingly. I think there is a typo here. Spelling says true. Yeah. So accordingly to tile map and transform tile to mini FB tile in the process. So while we are getting the tiles from the tile set and inserting that in our background buffer, we need to transform that tile to mini FB tile set. Mini FB tile. Yeah, that's it. So get tile map is equals to self get tile map. Now we do this for I tile map. There should be some kind of map. Is there a map? Tile map. Is there a map in Rust? Should be, right? We are a functional language. Almost functional language. Rust array map. Oh, there is a map. This structure is created by okay, so map. Oh, so it should be something like this. Ether map. Wow. Now we can use closures like this. And so this could be like a temporary buffer, and here is tile map, I think. I think that's it. Or, yeah. Yeah, I think we don't need to use iter mutate because we will not mutate the tile map itself. Or we will. No, we will not mutate. I think this map should return something, right? Oh, see this? If you are doing some sort of side effect, prefer for to map. Don't do this. Which is what we are actually doing, because this won't even execute. It's lazy. Rust will okay. So map is lazy. Yeah. So, well, besides it's cool to use map, we don't use map here. Okay. Anyway, let's do our ugly, old, but still nice 4. Using range at least. Tile map. Okay, so for each tile, so we will get this, like let tile will be tile set because this is not a vector, this is an array. If I use I can use iter here, but then this is a reference, then I need to use this. And actually yeah, so this will be tile map item, right? Let's see if that's true. Yeah, because iter returns all iterate over these lies. Let me check here. This should be a good time to me to understand better this iterator. Oh yeah, thank you for the heads up, Dan. Yeah, it's better. This way is much better. Yeah, because we are getting a reference to the contents of that one by one. Great, thank you, thank you, thank you. I think I can refactor a lot of parts here. I thought that iter only works for vectors, but it actually works for array as well. Great, that's great. So it's even easier. So I can get this and check. So let tile, it is tile set. What's that? Oh yeah, it's a reference that we put this. So what's the issue here? Tile set is have it here. This but we are not mutating. Oh, here? Yeah. No, this actually. Which var? Mutate. Mutable. This var, we are creating this variable right now, so it don't need to be mutable. Yeah, the problem here is somehow it's not accepting me to index it with a simple. Let's see what's there. It says slice indices are type of view size or ranges of view size. What happens is if I put like this one is okay. Oh, this should be okay. Oh, huh. Yeah, it should be casted to usize actually, because index could not be an U8 or something. So yeah, it should be usize. Great. So now now we have the tile. Now we need to let minfb tile, which is self transform tile to minfb tile, which will receive the memory management and the tile. Okay, and then I will get self background buffer in the same place, and what's the problem here? Oh, again, same problem. And then, oh, so now one thing here. Our vector should be, well, we don't need to use a vector. Because we know the size. So don't need to be a vector. It could be actually an array. And here should be an array. But the array type is the same type that is returned by, so this. Of course we can create a structure, something like that. It was to make it more like clean, but this way it works. So I will put like oh, actually this is this. What's the problem? Where we are printing it? We are not printing. Oh, okay. So then we have like 0, 8, 8, why is that? Because one tile, this is one tile. This buffer is made of 206. Oh, then it's not. Yeah, sorry. It's 32 per 32 tiles. So this buffer is already formatted by tiles. So now, yeah, now it compiles. So now, let's do this. If our screen is bigger enough, let's change something here. Let's change our screen. Instead of using this, let's use full screen. Okay, so back to here. Let's say that our screen is not 100 per 160 per 144, but it's the complete background. Just to avoid making this calculation before showing anything to screen. So now We are populating our buffer. Okay, now I just need to get a pub function, get background buffer. We take self and just return our okay. So now we have our background buffer. So now we can do like let background buffer equals to okay. Now the only thing that's missing is transfer this buffer to the screen, right? Actually, but we don't need this. This should be made here, and then this is for each tile. Oh, here we have so yeah, now we can do this for min fb tile in background buffer. I think this will print everything in the screen. No, it fails. Oh, sorry. Ether. So now, since this buffer is 256 per 256, actually 32 per 32 mini FB tile, and I already know how to oh. How can I put an index here? Because I also want to count here. Thanks. Thanks, Dan. Yeah, enumerate. Then it will return a tuple. I think that's it. Like let me just check here what's the index come first, yeah. So these will be m times 32 times 32. Is that well, we have one background with So no, I think this is fine. Or not. Okay, let me think. If I let like this, it will print one tile over other. See, if I do this, it will be blank. Oh. Oops. Something happened here. Okay, let me see. Stack Overflow. Wow. Why Stack Overflow? Oh. Yeah, because arrays stored in the stack and we are storing too much in the stack. Yeah, then thank you for that again. So that will be vector. So this is like vector of this. Can this so wait. Okay, let's solve this. Our tile, minfb tile, is an array. So this is wrong already. Oh, thank you, Live Doomax, for the following. Thank you a lot. Appreciate that. I really appreciate that. So we have this. We need to handle that in a vector. Vector Rust. Oh yeah, that's a vector inside a vector. Okay, so let me. So this could be like vec of vec. One, two. Is that? be back. Oops. Okay. And back. Then back. Well, you do vac. Yeah, yeah, but the problem is that our logic here actually is not U8, it's U32. I'm just following the same logic of our previous calculation of a minif bit tile here. Just to avoid refactoring that now. Because I'm eager to see that in the screen. Just that. Yeah, but I need to change this to be a vac of vac U32. Yeah. So vac. Well, this is the same. What's the problem here? Oh. Cannot move or out of... Yeah. Now, I think I was avoiding vectors and using array, just afraid of the ownership stuff. Because now it's that cannot move out borrowed content. Well, I can... I can return a reference because we will not mutate or nothing. Well, now it should compile at least. Yeah. So as we are not using the index here, it's just what you said. You cannot use one-dimensional vec and return a slice, not a vec itself. Otherwise, I don't see how easy of the solution. Oh, you can use a one-dimensional vec. No, I think we can use that bidimensional. Actually, the tile is already a bidimensional vector, so the background buffer is a three-dimensional because it contains bidimensional. It's a vector of bidimension. But now the only problem here is, let me just do this. Okay, so I think we can put like this. No, still not what we want. So let's think about this. Each tile. So okay. So here we are printing the screen tile. What is tile? It's 8 pixel per 8 pixel. Great. So if we are printing the next tile, so the first tile is there. So it's the second tile should be 8 pixels for I think this. No, not yet. So let's draw here. So our screen is like we put 8 pixels per 8 pixels, and that here is our first tile. So 8 per 8 is our first tile. That's great, that's good. Then we need to shift 8 pixels to start the second file. The second, and also what's the size? It's 24. Hmm. but times 8. So we have 1024 tiles. The screen is 1024 also. Yeah, so this 8, so let me copy what you said here. You said this, you said this, right? So 8 times I. No, we need to take in account the yeah. We need to, because why we are doing this? This is because in the mini FB tile, I is the line and J is the column for an 8 by 8 pixels. So one tile. So maybe we can do this. M divided by 8. Because we are putting the offset of because this counter will go to the 1000. Let's see if this works. No. No. Let's stop trying. Let's do some math. Or even change the representation here. So let's get back to, because we are doing this crazy to just because of this function. Because still here, well, still here, tile is a simple array, one-dimensional array, and here it becomes a two-dimensional vector. So we actually don't need that. But why we are doing this way? We are doing this way in two-dimensional because of this. Because it's a line and column. So let me think about this and try to change the Hmm. Let's see, let's see. So this color is 1 pixel. Okay. So let me do this. I will change. I will just put this as in one vector of U32. Then I will change this to a vector of vectors. Wait, there is something wrong here. Well, I think in this change to so how this could be a vector of X actually. So it's 8 by 8, so 64 pixels, right? And I will put like continually. So how that should be. Now I think you are right. Now this should be something like yeah. Okay. Then we have a vector of then this should be this should be so now we have a b-dimensional vector. Okay. But first, well, that will not even run because yeah. So, but before that, let's make our little r. Sorry. our little R works. With this new way. So how is that? Well, that's the same. But the here is like yeah, here could be a problem. Cause this tile, oh yeah, it should be but we are not showing anything in the screen yet. Oh yeah, because yeah, our R seems to be there somehow. Yeah, I think something is wrong here. Maybe, just maybe. Let's do the same. Just transfer that. Yeah, I think this will work now. No. No, 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 no. Yeah, not. Nope. Oh, wait. Now maybe I think it should be completely different. It should be something like for tile in screen. Right? I think that's that. Oh my gosh. That's okay. No, 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 no. Why? Oh, why? Because, yeah, now it's because we have our... No, yeah, okay. So, right now, our pixels are, instead of being like this in our uh, minifb tile, it's like continuous. So I think we need to get back here. I think here is good. So per each, now maybe that, so per each 8 pixels, I need to so should be something like so the problem here is this. We need to put, we have all those bits in only one line. So this come here. So how to put this, if these are all in one line, how to break this and put this here? We have in our screen buffer, we also have only one vector, but we know that screen has 256 in a horizontal. So for doing to the next line, we always need to sum. So let's say that the screen is like a 4x4. So we have like, no, like 20 stars to random. So we have like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say that we have 12. So you need to do this: 1, 2, 3, 4. Instead of continuing, we need to go. So the index will be, and let's say that screen is, so let's say that we need to print this 2. So when we get here, we need to get back there. So we need to use I when we get 8 to the crazy pseudocode, might be insane. 1 plus 8 divided by I divided by 8 times the screen width. You mean, let's see. What you said is I plus I divided 8 times I think this is enough. We don't need to have the other part because we don't have offset here now for only one. I think this will print. No. Yeah, almost there. Oh, because we are not returning. Yeah, because we are continuing adding this I. And we need to reset this I when we pass to H. So I think no. So this, so this is for going to the next line. Yeah, you are right. Then and this is for going to the next line. That part is completely right because we have I divided by 8 times the width. So each time that we get here, we divide it by 8 and we get to the next line. But the problem is that as we are summing up with I, it's getting this way. We need to get back there. No, I was thinking on I. So actually 8. No, I minus 8 or something like that. 8 minus I. Nope. Oh my gosh, this should not be so hard. Well, let me get back to this form just to see one thing here. Forget this for now. Here is something like J plus I times 8. Right? Wait. Here? something like this. So the module. So, but when it's 0, will be 0. When it's 1, it will be a fraction, and then it will not be able to even. Oh, that worked. It put that in the reverse way, but that worked. Yeah, but now how we can. So this, yeah. But do we need to put something like this? No. Okay, so now the problem is that the problem is probably not here. So thank you a lot, Dan. Yeah, you're right. So we get the module of iterate, which will make us to return the carry the pointer to the left when we pass the 8 bits. Then we get next. Yeah. So zero, then 1. Oh yeah, yeah. Because after the first line, it will be this will be 8. After the second line, it will be 16, and so on. Yeah, you are right. Thank you a lot. But anyway, it's still printing in the reverse way. Let's just do one thing now. Let me just get back to our. So we are back here. I think here it should be something like. I don't know. Maybe. Yeah. Now we have our R printed correctly. So now, yeah. Now we are able, because now everything is a vector, and we know how to print one tile. So then we can populate our buffer and then do something like for actually here it calls pixel. For min fb tile in background buffer right. Now we need to do the same. but per tile. If we do this, oops. Oh, sorry. Yeah, we will override. Oh, let me do something here. Okay. So now we need to, yeah, better move coordinator which match to separate. Better movement. Yeah. So okay, but now we need to pay attention in the number of tiles, because this should have, let's see, oh, this is a vector of a vector 32. And now this is, I think this is simple. Everything here should be put like this. No, wait. Let me think. So we will have 32, right? So if I print this, it should have 32, I think so. Yeah, 100. Yeah, it's 32 per 32. Yeah. So actually, the offset for this, for M, is 32. So it's 32. I think that's it. So we have offset for pixel and offset for tile. No. That's not true. But then it should be horizontal times. Oh yeah. So horizontal. So you are saying that let's put this in H tile H offset tile V offset pixel H offset pixel. So what you are saying is, so let horizontal, so H set. Oh yeah, it should be times, at least in horizontal, because it should go to the yeah. And here yeah, it should be times as well. The good Ole. Oh yeah. I'm from Brazil. I'm not from São Luís, but I used to work there. So when I was there, I bought this and one for the blues. Where is that? Well, I have one of blues as well. Cheers. Cheers. Actually, I didn't win a game or the Cardinals, but I won a game on blues, a hockey game for blues. And I was there in St. Louis when they won the cup this year. Yeah, I was there. I didn't went to the games, but I saw the party they did for that. It looks like a World Cup for us in Brazil, a soccer World Cup for us. That was the same for them. Yeah, that's not what we want. So, yeah, it was wild. I saw a lot of people like V offset. Oh, here. No. Oops. Something here is going out of bounds. I think these are divided. I think it's divided by, because we don't need to count it twice. Wow. Not there yet. Uh, this is not a framework. It's a pure Rust. We are using Rust. We are using a library called mini from buffer for rendering the UI. But that's a simple from buffer. We should put something like this. It's a vector of 256 per 256 colors like this, and that's it. We need to put that, and we are putting that from the DMG, from the ROM of Game Boy game. The problem here is that we know how to put one pixel. One pixel is there. One little pixel is working and working fine. We can put that like pixel, pixel. So this is working, okay? No, this is not working, why? Oh. So this is working. We are seeing the little R here. But when it came from, try to display less tiles on the version that would crash because I went out of bounds. It went out. Yeah. Well, anyway, I think we are good now because we are already displaying. So let me try one thing here. Let me do one thing here before trying that. So we have this. We have our background buffer, and we know how to okay. Each tile is 32 per 32. right? Yeah. Thirty-two. 32 tiles. It's a one kilobyte array, actually vector. It has one. Actually, it has. Oh, sorry. It's not one. It's 32 per 32, but so it is one 32 per 32. It's 1 kilobyte. How many tiles? Yeah, 1024 tiles. Yeah, and 32 tiles. This we already did. So wait, let me think one thing here. One of those tiles are our R, right? It should be our R. What happens when I try to print it? So each one of these vectors is one tile. Actually, I need to initialize it with this. So yeah, that black. Yeah, if we initialize it with light, we can see that, no, sorry. So if we initialize it with light, we can see that nothing is drawing. I mean, from the R, nothing is there in the screen. Try displaying the first line of tiles only. The first line of tiles is empty. That's the problem. Let me do something here. If pixel is different from, I will just only print if the pixel is different from the lightest. Why that? Just to see, because our R is printed with other color. So yeah, we have something there. Here. Okay. So if now we use, let me, just to be sure that we have our, yeah. So with this we prove that our R are there, because we are only printing our R and it is there. So let me do something here. And our R is in the position 25. So it's the very, so it's still in the first line. Let me show one thing here, because that's what we tileset screen with. But and what about the, oh, screen width? So why that? Well, let me understand here. Because 8 pixels is one tile. That's true. But anyway, we can't use some. But then we cannot, we need to divide that by the, let me see. Nope. Nope. Cannot even get there with this. Yeah, it's too long. Yeah, because this is a time. Yeah, but about that, skipping that 8 lines, we are already skipping here in the pixel offset. Because when the pixel oh maybe I think we need to do both offsets together. Like let me put this. So let me do this. H offset. Okay. So H offset is so the pixel offset is just modulo 8. I modulo 8, right? But that is for one. It's I is the index for one line inside the pixel. So now taking account the number of pixels, we need to I think it's it, right? So because we have no, that's not true. We need to some yeah. So this is the offset, but we need to increment the number of tiles. No, so it's 8. Yeah, this way we will be skipping 8 lines. Yeah, we will be skipping 8 lines. So then we can this is the H offset. And then the V offset. So the pixel V offset is I think should be times Let's see. Nope. Our R is there. So I think the vertical is right, but the horizontal not. So the vertical H. So why this is 8 more? It's because we will because that no. Wait. Okay, so what if I do this? So this seems to be no. Something is still wrong. Oh my gosh, we need to solve this. I want to solve this before wrapping this today. So if I get CS degree, well, no, actually not. Yeah, maybe that's missing here right now. What I need to do here is to put the age of no, I never run a GBA. Actually, this is not a GBA. This is a GB. This is a Game Boy Emulator. This is not a Game Boy Advanced, and I never did that before, even in JavaScript. I'm learning Rust and Game Boy emulation in the same time here. I think we are doing good. We are close to that. We are at least one pixel in the screen. We are able to one tile in the screen. I am able to put. Wow, where is the Oh yeah, it's because the wait. So so okay, let me put this way. Our horizontal is modulo 8 because after we do the next line here, we should make the pixel get back to the beginning of this line, right? So that's why we do I modulo 8, because when it's the bit this I goes when this I goes multiple of 8, we will like when it's 8 to 7, it's go here. When it's 8, it's the next line. When it's 16, it's the next line, and so on, because of this. So to get the age offset for the next tile, it should be the how many tiles it's a red put, which is 32. Well, let me do something else here. Because our Oh my gosh. So yeah, I think I'm getting out of time, but I want to show this. Uh, so we are going pixel V, but pixel H. I want to show. So inside the minif beta, it is. So I have 1024. I have 1024 tiles to show. Each tile cubes 8, 8. I divided by 8 times width. Get the next line. So for getting to the next line, oh man, I want to finish this today. I want to finish this today. We are so close to show the actual tile set there. Okay. So let me Okay. What's that? Okay. So the I is going from 0 to 1 to 63 because that's the size. So each pixel occupies, each tile occupies 63, actually 64 spaces in this screen. That's good. Okay, so the horizontal offset should be added. So let's put this way. So the horizontal offset should be added to this offset in each interaction. I'm getting out of the ideas here. Oh my gosh. So let's just recap what we did. We refactored the min of b transform to min of b so we refactor everything to work with an array, a vector, because while we put every tile set in the memory, that makes a vector. Oh, but I can't. Instead of getting back What if I use a two-dimensional array? Yeah, actually it's already two-dimensional. Oh wait. Okay. Let's draw. No. So why we are doing this? This is we are some this. Let me do this. Pixel percent pixel offset. Okay. So A1. So 64, it's 8. 64 divided by 8. Something. 64. 64 module 8. That's 8. Actually, it's 0. But 63 is 8. Okay. Just to... Yeah, guys, I think I need to go. It's too late. We'll get this problem to solve tomorrow. It should be an easy problem. I don't know what's the problem. Why? Tile v offset. will do 10 minutes here. Let me check. So I per 8, it is every time it gets the first line. Okay, but when we are in the, it's still there. So we have 32 tiles. When, oh, thank you, Emit Nu. Thank you for the follow. Thank you a lot. We are trying to solve a problem here. How to print this in one vector. So then we have so we are 8 bits. When we are in the second tile, instead of starting in 0, it should start in 8. Actually 7, yeah, 8. M8. Yeah, but maybe why is that? Because and 0, 0. When is 1? It's 1, 1, 8, okay. And it's 2, okay. When is 3? Yeah, I think at least this way. What's the problem? Nothing yet, but that's because our vertical offset. So now, how to make so why this is this way? It is this way because I divided by 8 will be like the first iteration, it will be so this is 0, so this oh yeah, it will just go to the next line when this is multiple by, yeah, but we need to aggregate here. So for example, when I is 8, it will go to the next line, because it will push the cursor to the one line for okay. V offset on screen. Oh, the tile width. We did that. Oh, I think we get at the set. This should be inbound. So let me try the V offset, because I think the H offset is right there. Tile weight is 8 as well. So what you mean here is so this is the pixel. The pixel plus width. No, this is never works, because it will get out of bounds. I think so. Let me see. No. No. Nope. So this is for one line, for one pixel. This is V offset. This is for getting to the next line. But when it yeah, it didn't work, then I think this is right. So your H is right. So I 8. So the tile width is 8. So that's fine. And this is because, but here I don't actually know why this is. Well, folks, well, today we got this. We We are about to print this in the screen again, but now following the tile map. I need to stop now. I really would like to continue, but I can't. So tomorrow no, on Monday I will continue with this. We already get a very good step forward here. We are about to print the right stuff in the screen, and that's amazing. We are already able to print, but now we are getting from the tile map, putting that in a background buffer, and then putting that back to screen, which is awesome. Let me try one little thing. Let me see here. Here, populate background buffer. What if I just push this? If this buffer is not a vector of vectors, but just one vector, okay. Yeah, but yeah, and instead of I will do this. Because the Game Boy already do that for us, right? So we don't need to do that ourselves. So is this correct? Actually this is Yeah. So now actually we can do this. Yeah, maybe this works. What's that? Well, this is not doing the. Well, that's it. I don't know. Yeah. Tomorrow we're gonna test more. Okay. Thank you. Thank you, everybody. See you tomorrow.